people who are behind OpenStreetMap. So we're trying to get beyond just counting of how many nodes or ways are in the project or how many change sets, but trying to get a feel for who is behind that and what are some qualitative things that we could bring into the analysis of OpenStreetMap that would supplement all of the computation that we can do on the data. So just to describe where I got to in the early part of my work and how I got to what I'll show a little bit later. I started out by looking at the comments that people leave when they save their work in OpenStreetMap. So if you save your work, that creates what's called a change set, and then you're allowed to put in a free-form comment describing what you did. And so I was running some automated language detection software on those comments to try and figure out the mix of languages coming in, and particularly whether English could be used as a reliable proxy for understanding non-local influence in the map as opposed to local influence. I won't go into this in detail today, but this is one map out of that study where it showed a high percentages of English usage and were occurring in more rural areas. And I guided my study towards trying to look at places that are not typically looked at in the literature around OpenStreetMap right now. One of those was Global South, and so I chose South America as an area of focus for several of my studies. Another one was in smaller cities, so outside of major urban areas. Can small cities be used as a barometer of OpenStreetMap health? So I looked at a number of them, and I started focusing on cities of around 50 to 100,000 population. Here's one, for example, in Argentina, where we see a road network and some basic infrastructure, some natural features like streets. But how many people are really behind this map, and what can we learn about them and their motives and origins? So one technique that I used to understand this was breaking out each contributor's work into a small map and using small multiples. And so, for example, in this city between 2007 and 2014, I identified 29 contributors. And you can see that some of them spend a lot more time here than others doing different things. We also have information about the geographic extents of the edits. So when people edited a small town, this is another small town in Argentina, General Pico, which is right in the center of the country. When people edit that small town, are they doing it as part of a larger effort that covers a big area? Or are they just focusing on that town when they save their edits? And when you connect this up to language use, you see that people approach the project at very different scales. Some people are editing across the country when they pass through this town, and what they do is just one little piece of their overall editing. Other people tend to save their edits more often and locally. And so when you see those that are commented in English, those are tending to work at a national scale or a very local scale, whereas the Spanish commented edits seem to cover the provincial region, more range of types of edits going on there. And so reading through these comments, I was trying to develop a topology of contributor roles and came up with the conclusion that people can approach the project in either casual ways, where they have a favorite place that they just add to the map maybe once or every now and then they make some edits. There's also systematic approaches where people are trying to map an entire town in detail, and then automated approaches. And these are the influence of things like import scripts that bring in data that's already publicly available and imported into the project, or bots, which are automated programs which make fixes, systematic fixes. And I won't go into this in detail here, but I've collected a lot of evidence through different types of comments people make that are associated with each of these types of categories. People also approach the map for different reasons. A classic one that's come out of OpenStreetMap studies is the love of place. I call that total feeling map. So somebody has a real intimate connection to a place and they want to put that on the map. That's one reason they map. But we also see a range of other influences. We see paid mappers, people who are working for a company or a government that has a vested interest in the quality of OpenStreetMap data. So they pay individuals to edit the map. There's also people who approach the project because they love one particular type of thing. Like people who are nuts about bike trails or railroads or power lines. And those can be easy to identify sometimes by looking at the profiles people create. Another reason people might come to these small towns or out of the way places is through event mapping or crisis mapping. Similar to some of the MapCon work that's going on here, that's related to a special event, a mapping party, or a response to a humanitarian need. So that's some of the background work that led to what I'll show today. When I had these static graphics showing the work of different contributors, I wanted to make that a little more interactive so that people could explore in more depth different facets of the crowd. And so I used an approach called visual analytics, or more specifically, geovisual analytics. This is a domain of research that grew up mostly after 9/11, when there were large amounts of data and people wanted to analyze it, sometimes in real time for national security purposes. So we had a lot of federal government, U.S. influence in the study of this, as well as academia. And the focus was on how to make sense of these big, messy, heterogeneous data sets. And in some ways, OpenStreetMap does fit that bill. I mean, the data is not unmanageable, but it is big, and people can tag any feature with any type of tag. So it's a little messy in that regard. And then when we add mapping and spatial aspects to the data, we get this subdomain of research called geovisual analytics, which I think is pretty exciting and applicable to OpenStreetMap studies. So I created this tool for analyzing OpenStreetMap influence called CrowdLens for OpenStreetMap. It's available here. I invite you to try it out. Maybe not while demoing it, but afterwards. And then it is designed to be viewed in like a laptop-sized screen or a desktop computer. So I don't know how it works on an iPhone, and that's not the intent. But I do welcome you to jot this down and try out this tool. The purpose of it was to help answer questions like how many people are in the crowd behind this crowdsourced map in this place, and how many of those are likely to have local knowledge of the area. Also, as we move across the map, how does the contributor attention vary? And in some of my work, I relate this to literature and critical cartography, cartography of silence, how those apply in the digital age. I won't go into that today, but it's a topic that's very interesting to me. And also, there's other things that haven't quite been studied very often, such as why do people leave the project? Or why do they just come one time and map one thing? What are they doing when they do that? So this tool is helpful for that. And the main goal of the tool is down at the bottom in blue is can we help people to understand if they can be confident in the amount of attention given to the OSM data in their place. So when they're deciding whether or not to use OSM in a project, can this help professionals to understand how much attention is given to the map, and therefore make decisions about whether or not to use the data? In open source software development, Linson's law says that given enough eyeballs, all bugs are shallow. So how many eyeballs are on the map, and can we be confident with that amount? And that's something that could vary from project to project and person to person. So I'm going to do something I've never done at AAG, which is attempt a live demo on the internet with software, and we'll see how that goes. I have backup slides, and it doesn't work. So this is that CrowdLens tool that I mentioned. When it loads, there. When it loads, it's got the city that I showed earlier, Tres Arroyos, but I added the 2015 data, so now the crowd is larger. There's been 41 total I could identify. And down here, this should look a little familiar. It's similar to the slide I showed earlier, where you have the small multiple maps of each contributor's work. And these can be sorted and then clicked on to learn more detail about any individual contributor. So we could change this and how we see this person's edits. If we want to learn a little more about him or her, if there is a profile or link page that's detected that the person created on the OpenStreetMap website, we can open that and learn. Here we learn that the person is from Argentina, but not much else. And this amount varies depending on how much the contributor wanted to share with the world about their background. But we do have a lot of stuff that can be derived just from the metadata and the OpenStreetMap history files. So things like total change sets in the project, the amount of change sets in this town, and we can also use the language detection to understand what is the language that this person most commonly uses in the comments. I've also added a tag cloud here, so these are all the tags that the person has used. Larger text means that they use the tag more often. So here's one of the hobbyist type of contributors who focuses on mapping power lines. Clicking that would show all the people that worked on power lines here. There's just two. Let's set this back. Okay. And down here, that's confirmed when we look at the comments. So there's a table with each change set and the date and the comments. And we can click the change set to see what they were working on at that time. For example, if we want to know when this road was edited, we can click it and it would highlight down here. So we can learn a little more about that editing. We can also sort the crowd, for example, by the percentage of change sets here. So this would be a way to identify people who edited here and nowhere else, and these one-time contributors, perhaps. A lot of times they don't leave comments, but sometimes we get a clue about what they were doing. There's somebody who just added one road in the north or east of town. Maybe this person is from the area and would know that. Another one leaves a detailed comment about what they added. They made one edit in the project ever. They were adding a school, presumably a Catholic school in downtown in this area based on the text of the comment. And so perhaps this is part of their personal geography that they were adding to the map. In contrast, as we scroll down, we see people who have made thousands of change sets in OpenStreetMap. This person has over 35,000 and just came through this town twice to do something. So coming to the map from a different purpose. The map itself is also a filter, so as you zoom in on a downtown area, the crowd gets smaller, and so we can just see the size of the crowd in each of these areas as we zoom in. I've also added in some other cities, so if we take a look at one that's about the same size, but in Australia, this particular city has a crowd that's about twice as big that's worked on it. We can narrow this down to certain subsets of the crowd. So, for example, if we wanted to see the people that are most active in this city and have been active recently, use these filters on the left. So maybe we want to weed out the one-time contributors and filter this down to people who visited here at least three days. And maybe people who edited within the past, at least once within the past 2 years. So that narrows that crowd of 85 down to just 5. And we learned that the active crowd may be a lot smaller than the total crowd. Again, we can click on these and go to the profile pages to learn a little bit more about where they're coming from and whether they're from this area. Sometimes the user comments also reveal this type of thing. For example, here's a comment about making a survey of street names. You might be more confident that this person was familiar with the area. And therefore, if we were deciding whether to use the data here, we could understand that maybe a few people, at least in this town, have been walking around and verifying some of the edits rather than it all being traced remotely from aerial photography, for example. Oh, I want to show a few more things. I've loaded in cities from around the world, and you just get an idea of different amounts of attention given to different places. So India, this city, we have 19 contributors in the crowd. The highest number of active days is 7. If we filter this down to like power users in OpenStreetMap, people who have made at least 1,000 change sets, this doesn't get very much smaller. So 12 out of these 19 have made over 1,000 change sets in the project. And this shows that this area is largely being mapped by OpenStreetMap power mappers who come through the area that may not necessarily have local knowledge of this place. It seems unlikely. In Ghana, in this city, for example, the crowd is 14. We can use these filters to understand the amount of attention given to different entities. Like if we put highways, 12 out of the 14 maps highways. Or in OpenStreetMap, this tag is used for all roads. So 12 out of those map roads. Things like amenities receive less attention. Amenities are things like schools, churches, hospitals. They may have more relation to the routines of people's everyday lives. I think that amenity mapping and understanding the amount of attention given to amenities may be a fruitful area for future research in OpenStreetMap. Talk about some of the design process that went into this tool. So we put it through multiple stages of user evaluation. The first was an early usability test where we had 7 students in the social sciences use the tool. And we were trying to just figure out things in usability related to, was the interface clunky? Could people figure it out intuitively? And could they use it to answer set given questions that we fed them? And the next was a scenario abuse exercise where we basically wrote a story about how we thought people would use the tool, and then included elements that might be useful. And then the third was actually giving the tool to people who use geospatial technology in their daily jobs and OpenStreetMap to see how it affected their perception of the data. So I'll talk briefly about the results of each of these three tests. In the early usability test, most people were able to navigate the interface, but they did give a number of suggestions which were very helpful. I won't go into detail on all of these, but one of them, for example, was the small maps at the bottom used to be a lot bigger. People said, you know, you could make those smaller so that we could see more of them at one time. That would help us out to understand the interface. And so those were examples of the types of feedback that we received during the earlier round of testing. In the scenario use, we wrote two scenarios about how we envision people using this tool and answer questions about OpenStreetMap data. I think in one scenario we had a person who worked for a city government that was trying to decide whether or not to incorporate OpenStreetMap into geospatial services in the city. In another scenario, we had somebody who worked for a nonprofit organization, and she was trying to decide if OpenStreetMap could give her an indication of the amount of people who were actively working on the road network in the area affected by in the area that she was working in. And so through these scenarios, we decided to put more emphasis on the crowd filters. We realized that having the ability to narrow down the crowd in certain subsets would be really useful for answering questions. And so that helped us to prioritize that piece of the development. When we gave the tool to professionals who use OpenStreetMap or who have considered using OpenStreetMap, we wanted to know how it affected their perception of data quality. So if you could see all the people who worked on OpenStreetMap, would that make you more confident in the data or less confident, depending on the size? And for a number of people, about half, they were ambivalent. They said, well, we already know OpenStreetMap. We have some concerns about it. We use it a lot. So this tool is interesting, but it didn't really affect us one way or another in terms of confidence. Another half said that it either slightly or greatly increased their confidence in the data. This was a little bit surprising to us. I thought that some people might see the smaller crowds and be concerned about using the data. None of the testers reported that. I think it's a powerful image to see some of those users who have made hundreds of edits within a count, and they mapped every street. That was, I think, striking to some of the people who looked at this. So here are some examples of comments where seeing the large number of different contributors makes me more confident that errors will be fixed. That relates directly to Linus's law type idea. Others said, well, you know, you could count the number of editors and that may be a good indication of accuracy, but it might not. And people cited cases where they've seen hidden runs, edits in OpenStreetMap where they know that some of the data is wrong, so that therefore they have more concerns about it. The professionals really had some great suggestions about the tool. The main thing people wanted to do is be able to select any bounding box in any part of OpenStreetMap for analysis. This would be wonderful, but also a lot more challenging. I don't put it past any of the researchers here, however, to figure that out. There is a lot of pre-processing required of the data to create those map images, as well as pull in a lot of the statistics are pre-computed for performance reasons. So that would be a challenge. And then some people said, well, there's two adjustable elements on this page, and that was somewhat of maybe a reality check that we would need to simplify this tool to some degree for a broader audience. Right now it's designed just for people who have real deep knowledge of OpenStreetMap and want to adjust all of those parameters, but not everybody would want to do that. I would like to thank especially Alan McKechnie, who has served as an advisor on this project, as well as a co-author on a paper that we're working on with this. He contributed a lot of help towards designing these usability and utility tests that we started. And also Greg Milborn, who is an undergraduate research assistant, a real all-star with scripting, who helped with some of the data processing and early prototyping of this application. Again, I invite you to go try this tool. Please provide feedback. My email's in the lower left. I'm happy to hear about your thoughts on this tool and how it can be more useful. There's 6 cities loaded into it now, but it's designed so that we could plug in additional ones for specific research questions. For example, future, I'll be looking at conflicting OpenStreetMap among editors, and there's certain more controversial areas of the world that could be plugged into this tool that learn a lot of things about how people go back and forth in the disputes and discussions on OpenStreetMap. So thank you for your attention. For questions, if you want to move
You're perfect in time. You're perfect in time. So maybe wait till
yeah, I think we have space at the end where we can discuss.
Yeah. Okay.
So again, my name is Indy, and I made a slide. All of the analysis that was done for this presentation is up on a GitHub Pages site, and so I invite you to view this page with me as I go through the analysis. You can also find me online via Twitter. I'm Indy Mapper. So what I wanted to talk about was some data analysis I did of India, and I'm going to do my best to distract you with show me the way as I talk about some of these things so you don't just see a wall of text on the slide. The thing that I've been interested with OpenStreetMap has been the history of edits over time. One of the things that I find most interesting about how the data is approached for analysis is that it's often evaluated as a snapshot in time. And so you hear anecdotal descriptions of OpenStreetMap and the data quality itself, but oftentimes people aren't looking at how it's progressed and how it continues to progress on an actual daily basis. So for this presentation, I am going to talk about 3 cities in India. And here is an overview map made by one of my colleagues at Mapsen. We're looking at Delhi, Mumbai, and Bengaluru. And the reason why I was interested in looking at cities in India is because they have had an incredible increase in the number of people that use smartphones and that have internet access. And I always find that the way people approach maps is so different than other types of media. You often hear the expression, don't believe everything that you read. But for some reason that hasn't translated so well to maps. People look at maps and they just believe everything that's there. So that makes data quality related to maps even that much more important. So data analysis, it means many things to many people. But revealing trends and assessing quality are common goals. Map data can contain many types of features worth investigating, and it's the data ranges in complexity due to the diversity of editors and the diversity of features they contribute. When we're thinking about data quality, people often ask, well, what exactly does that mean? What exactly are you measuring? And it can be quantitative, it can be qualitative, it can be something where you are comparing it to something else, the superiority of the data, how complete the data is, how current the data is. All of these things can be extremely important when you're evaluating any type of data set, whether it be spatial data or any other. In recent years, researchers have developed a number of techniques to assess OpenStreetMap data. Analysis of roads is very common. What I found in many studies is that people will use a proprietary data set or a public data set, and they will compare that to OpenStreetMap. And what they often find is that they spend most of their time conflating the two data sets, because the diversity of tags within OpenStreetMap is far greater than the data set that they are using for comparison. And so you'll often see a discussion of heterogeneity within the data, and it often comes across as problematic. But I find that that's a difficult thing to state about OpenStreetMap. Just because there are more tags doesn't mean that that makes it problematic. It actually makes it a much more rich data set than what you might find in a proprietary data set or from the local government. But when you have many tags that describe similar things, you do have to figure out a way to bring those features together so that you can make sense of the map and the data. Additional analysis that I've come across that I have found to be really interesting is analysis of potential vandalism within OpenStreetMap. So I have to get questions about, well, since anybody can edit the map, then don't you worry that there will be problems? Don't you worry that people will add fake features or corrupt the map in some way? And thankfully, I have other colleagues on this in this session that have already addressed this and will continue to address this. And it's because you have the crowd, people are catching issues and fixing them as they arise. And yes, it's true that some things stay on the map longer than they should, but this happens with every data set. And we see this, it pops up in the media quite often. One of my favorites from the last couple of months was an editor who became enamored with a TV show that aired in about maybe 10 years ago. And this editor decided he was going to add all the places from this TV show, a fictional TV show, fictional places. He deleted real places so that he could place these fictional places. And I was reading about this in the Talk US mailing lists, and it was fascinating. It was a type of vandalism, but this person probably just didn't recognize that this is not what you should be doing. And the community came together to help him stop what he was doing. There have been other forms of what you might consider vandalism that were well-intentioned and weren't intended to be problematic. One of those I remember was in 2007, 2006, sometime around then, when there were fires in Santa Barbara. And I was a graduate student there, and there were a lot of people who were contributing to an open map. At this time, they were using My Map by Google. And there was this data that was being published every day in a tile format that showed the boundary of the extent of the fire. And some members of our department would process this data and add it to the map so that you could see this boundary as a vector. And when people saw that this data was added, they would be so excited and they wanted to contribute. So what they would do is they would take the raw data and add it to the map, which was in a raster format, and it would cover up everything else that had been added. It was a type of vandalism, but it wasn't intentional. These are people that were trying to help. So you see these things happen on a regular basis when you're evaluating OpenStreetMap data. So when I was looking at the history data, I was thinking, how come more people aren't doing this type of work? And I discovered that it is actually quite difficult. So I have in here a selection of tools that people use. The IOSM Analyzer, Osmium, OSM History Splitter, OSM History Render Importer, Matplotlib, which is finally something that I know how to use quite easily. There are tools for Mapbox. There's a KeepRight tool, Osmosis, Map Roulette. And when you want to start evaluating the OpenStreetMap data and you're looking at the history files, the tools that you may be familiar with, like OSM or PGSQL, suddenly have very interesting difficulties. They don't know how to deal with all of the redundancies that come in those data sets. And then on top of all of this, all of these tools that do know how to split the data don't run natively on OS X or Windows operating systems. So in order to accomplish this analysis, I used a virtual machine to install all the tools that I needed in a Linux environment and split the data and then brought that data in to my local instance so that I could do the analysis. So let me tell you a little bit about what I looked at in the data for these cities in India. One of the things I looked at was the accumulation of roads over time. So you can see here that Mumbai is relatively stable over time. The number of kilometers being added doesn't change very much from year to year. But in Bengaluru and Delhi, it's gone up significantly. And if we look at the percent change, you can see that for 2008, Bengaluru and Delhi are literally off the chart. So you see that's kind of the start of where all this data was added. And if you look at the history for a particular area, it's very common to see that the streets are the first things that are added. And then over time, you'll see buildings come in next, and then you'll see other types of points of interest. And we saw this in the cities in India. In addition, we're looking at the percentage of roads with names. And this is one of these things where being a geographer really pays off, because it may seem that every road should have a name. And in the United States, it's very common that every road has a name. If it doesn't have a name, it might be that that road is a private road on someone's private land. But in other parts of the world, it's actually common for roads to not have names, that people refer to them by the area. And so in parts of India, they have sectors, which are an administrative area, a locality. And people use those to help them navigate. So while we may have plenty of streets in India that don't have names, it may be more important to make sure that we have those administrative areas, because that's what people will use to help locate themselves. Another attribute that's really interesting is OneWay Roads. And one of the reasons why you might want to consider this is because this is a type of attribute that you can have more confidence that you're getting local knowledge. If you have reasonable imagery, you can digitize roads, and you can be anywhere in the world and not know anything about the place. But if you don't have very good imagery, and you're not able to zoom in enough to be able to determine what type of road it is so that it's one way, then you can look in the edits and you might be able to determine that, oh, this is local knowledge, because you would not be able to digitize this from imagery. And we see that the number of one-ways is growing, this means that we have local editors. And in this graphic, let's see if I can make it a bit smaller. You can see the time series of roads being added over time. So here's 2006, 7, 8, or 9, 10, 11, 12 through 15. And what you'll notice is that the larger, longer highways are added first, and then the smaller segments are added over time, filling in the gaps. So that creates an interesting opportunity to look at the relationship between length and number of segments. I've seen plenty of analyses where people count the segments, and it seems abstract. Really, what you want to look at is the length. But with OpenStreetMap, you see that there's a relationship between length and number of segments. And you'll see that over time, you have more segments, and those segments are smaller. It's people adding in the details. So this is Bengaluru and Delhi. and then the Y seems to be doing its own thing. That's what happened here. Their number of segments went down significantly. The reason why you're seeing this difference, it can be explained in a few ways. It could have something to do with an API change that happened in this time period. It also could have something to do with the license change. And one of the things that has been really fascinating is I worked with one of our team members who has been very close to that process. And he said it was painful that when the license changed, a percentage of the data disappeared from OpenStreetMap and has not yet returned. And so we could look more into this to determine if this was a possibility, or was there a large import that was removed? Was there vandalism that occurred that had to be removed? Or was there a drop in participation in editors? But it is interesting to look at these differences. Buildings are another opportunity. Buildings accumulate. Once the road network is down, then the buildings get added as well. And buildings with addresses as well. You can see here that this analysis, it's very generous. I include all the queries as well if you're interested in them. This is a building or a point that intersects a building that has any address field populated. So if you're looking to do geocoding, this may not be adequate for you to get your work done, but we find it to be a valuable insight into the community and their efforts. So we have all three cities here, and you can see that the area, the number of buildings, and the number of buildings with addresses, there aren't many that have the addresses yet. And in many cases, this is something that you need local editors to contribute. We're also looking at the number of roads that intersect buildings. And looking at this over time, I think this is one of my favorite graphs here, because we can see that in Delhi, we suddenly have this huge spike in the number of buildings that were intersected by roads, but then you see it drop almost immediately. And this is a testament to an active community that's watching to see when things change and whether or not there are problems, anything is problematic in those edits. And that's exactly what you see. If you visualize this data, you see that there were several large features that were added that didn't seem to make sense of any kind of sense. They were immediately removed. So that is part of this explanation of why there were so many intersections. If you break it down further, though, to see what type of buildings are being intersected, it's predominantly residential. So the important primary, secondary, tertiary roads are less likely to be intersected by roads. Those types of roads, intersected by buildings. And this is a measure of higher quality. And the last thing I want to talk about is the points of interest. When we were looking at points of interest, we pulled in everything that we could think of for a point of interest. And we see that those numbers are climbing as well. The different types of points of interest: airway, amenities, barriers, highways, historic, leisure, man-made, natural railroad shop, tourism, waterways. You can go through and see what things this particular community is interested in. And in the final thing that we're looking at is the actual editors. And so in these charts, you can actually see who is responsible for the bulk of the edits. And it's your typical long tail analysis, where you have many editors that only contributed one or two features. And then you have some power editors who have added hundreds, thousands of features to these places. And these are just points of interest. When you start looking at road features and buildings, these numbers are, they go up even greater. But in addition to thinking about, well, how many edits of each editor used, if you look at all of the names of the contributors for these cities in India, it's very encouraging to see that most of them have Indian names. And that's an indicator that a lot of these could be local edits. These could be people with local knowledge. And we find that very encouraging. And if you're interested in this analysis and you would like to have the queries, or you would like to have the data, which means you don't have to install all the software, it's available on this website. Thank you.
Okay, so again, my name is Jenny Anderson. I'm a PhD student in computer science at the University of Colorado Boulder, studying human-computer interaction and human-centered computing. So today I'll be talking about work we've been doing on OpenStreetMap data analytics software platform. Collaborators on this include Robert Soden, Ken Anderson, Marina Kogan, and Misha Palin. I'd also like to acknowledge Kel Marin for his integral contributions to this framework. I'm coming from the lab project EPIC. That's Empowering the Public with Information in Crisis, the catchy title. And that is, we study crisis informatics. We seek to understand the use of social media and social computing platforms during disaster and crisis, and specifically the collaboration that's occurring across these platforms. As such, I'm sure I don't have to convince most of you in this room that OpenStreetMap and the work of HOT, the Humanitarian OpenStreetMap team, are incredible sites of study in this area. So to help kind of try to uncover these collaborations, we've been working on a framework that we've aptly called EPIC OSM. So, so from a human-computer interaction perspective, we want to understand how the people are collaborating on this platform. Stephen Johnson yesterday at OSM said OSM is about collaboration on a lot of levels. I've heard the word collaboration 150 times already. What does that look like in OSM? So far, we know that in crisis, it looks something like this. I was joking with Mikael yesterday about we're trying to fit these slides into every presentation. So this is Haiti, 2010, before and after the earthquake, kind of one of the first big convergences we saw during crisis. With people coming together and editing the map. So in this context of disaster, we have these massive convergences. And so what can we then learn about online collaboration? And then how can we learn from that to make it more efficient, productive, and effective? So to understand that,